Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. Before we start with our guest today, we have a worldwide WebRTC segment for you where we get a quick update from WebRTC conferences around the world. Today, we have Alfred Gonzalez from our team reporting from ComCon UK. And then we'll speak with Justin Williams from our team reporting from ComCon San Francisco. Stick with us after this segment, and then we'll be live with Sean DuBois from the Pion project talking about WebRTC, broadcasting, and taking your questions live. And then we'll close today's episode with an industry chat with Sahi Levent-Levi. Hey, Alfred. Welcome to WebRTC Live. Good to see you. You were at ComCon UK recently. How was the experience?
It was pretty interesting. I was able to like listen to some cool topics and yeah, just meet some new people. It was really interesting. Yeah.
Nice. Well, I'm sure Dan Jenkins and the ComCon crew took good care of you there, and I'm sure it was a really cool conference, as they always do. What insights did you have at the conference? Were there any particular talks that were favorites for you?
Yeah, there are a lot of interesting things they mentioned in some of the talks. There was one open source audio and video solution called Oryx, which I haven't heard before about. It seems really powerful, and it has many features, the usual ones like authentication, streaming, recording, transcoding, and all that. But it also integrates OpenAI, so it has live transcription and translation. Nice. And it also had stream recognition and video on demand dubbing, so it could translate the whole meeting. It's a pretty powerful tool, so I'll keep an eye on that.
Excellent.
Yeah. Oh. And
go ahead.
Yeah, there were also a few other things like from Dan Jenkins, which he talked about iceperf.com. Mm-hmm. And it's a tool to test the performance for both stand turn and specifically the time to receive a nice candidate, and also the latency and throughput for turn. And he did a comparison between some of the most important turn providers. And this was it went live just a few weeks ago before the JanusCon. And soon it will be live with live stats soon, really soon. And there were some interesting also new features coming up. So like testing media by default instead of sending small packets, and then analysis on the providers, on the costs, and testing open source and testing CPAS. So yeah, a lot of things.
Very cool. Yeah, certainly turn traffic is a really important part of WebRTC applications at scale. So be interested to see more as that project from Dan evolves. Yeah, Alfred, I know you'll be blogging more about this on our site at WebRTC.Ventures. So we'll have more information there from ComCon UK. Thanks for sharing your thoughts with us. And now let's go to Justin Williams at ComCon San Francisco. All right, well, Justin, thanks for joining us. I know you were at ComCon in San Francisco. How's the event been?
It's been really awesome. Well, this is my first time at ComCon. It's really awesome to see all the people that I've been seeing online on YouTube Live in person, meeting everybody. Everybody is super nice, super friendly. So it was really easy to talk to everybody. And yeah, having a great time.
Excellent. I'm glad to hear that. It is our little world of WebRTC people is, a relatively small, very friendly group. And so, yeah, it's always great anytime you get a chance to see people in person. So I'm glad you've had that opportunity. So yeah, tell us a little bit about something that you've learned or thought was cool about some of the speakers at ComCon.
Yeah, well, honestly, what I thought was really great is there's a good diversity of the topics that people are talking about. So some of the really interesting ones are, as we've seen Pion in the past, it's a Go implementation of WebRTC. We saw some demonstrations for Elixir implementations of WebRTC, which is very interesting. We've seen things that are in a little bit of a different realm. So like companies like Zipfront that have demonstrated a product for load testing WebRTC at a high scale, specifically around call centers. And then talks another one that was really interesting, and it was quite fun too, because there's a little bit of banter involved, which was to step away from WebRTC and maybe look at other solutions such as Quick over UDP, which solves slightly different problems. That's mostly what the banter was funny about. But we're looking at different solutions that people are bringing and working on, and it's just so interesting to see.
Excellent. You dropped a lot of great topics there. I think we just nailed down 6 or 7 future episodes of WebRTC Live with things we could talk about there. So, we'll have to keep our conversation short for today. But Justin, I'm sure you'll get a blog up on our site at WebRTC.ventures soon, talking more about what you've learned, and we'll provide some links for people to learn more about a lot of those topics you mentioned, and learn a little bit more about the banter around Quick over UDP. Look forward to learning that myself. Thanks a lot for being there, Justin.
Thanks a lot, Aaron.
All right, welcome back. We are live now, and thank you for joining us live today on YouTube, LinkedIn, and Twitch. Welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this, and we certainly highly encourage that. For today's episode, I am joined by Sean DuBois from the Pion project. Today, we're talking about broadcasting and OBS and WebRTC, as well as taking any questions that you have about WebRTC. So you can enter those anytime on whatever platform you're watching this on. If you don't already know Sean, he's very active in the WebRTC community. He's the creator of Pion, which is a WebRTC implementation 100% in Go, a developer at Twitch, and author of WebRTC for the Curious. Thanks for joining me today, Sean.
Dude, thanks for having me. All I can notice is that height-wise, we're not matched up, so I look like...
That's true, actually.
That's
yeah.
True. Yeah. Okay. Let's see.
Maybe. If you have a book under there, we should have talked about that before. I was just trying to assert my height dominance.
I did.
Virtually.
Whatever you want to talk about, we can talk about. I'm sorry.
No, that's all right.
Yeah.
Let's start by talking a little bit about the Pion project. What's latest with Pion?
Yeah. So with Pion, I got dragged away from it for. It's probably been a year now working on the OBS. I'm working on putting out a new major release with the V4, and I worked through some of the minor repos. Like I closed out all the issues in MDNS, and I'm making a new release of DTLS. So not really related to, well, I guess related to WebRTC, but DTLS is this really cool feature now, connection identifiers. And so one of the problems everyone had, where if you had DTLS traffic, you couldn't identify that it was like that there was like a network switch. You know, if you're sending DTLS traffic from this IP in port, you change your IP, you couldn't identify it. But now DTLS in the record layer has a unique identifier. So people that are doing WebRTC traffic or doing like little IoT things, it's really nice because you can roam between networks, and I can continue to identify you even if you changed IP in ports. And that feature is in the new version of Pion. So
nice.
Yeah, so that's a really exciting thing that's coming out in the DTLS implementation. I don't think most WebRTC people will care about it because you can solve it in other ways. People have solved it in other ways with WebRTC. They solve it in like the ICE layer. But if you're just using DTLS, this is a big improvement. Very
nice. Very cool. Yeah, really, really important as you're crossing networks and more Web mobile type of applications. I mean to say.
Oh, and another cool one.
Yeah.
So in DTLS, we've added a bunch of callbacks and hooks so that you can randomize attributes about the handshake. So I saw this there's a Tor uses Pion for Snowflake. And so Pion was getting blocked in a bunch of places, like in Russia, you couldn't use Pion for a couple of weeks. And so developers have contributed a bunch of things. So you can like randomize the order of extensions. You can even randomize like the client hello and stuff like that. Like all these like really cool things to get around people that are blocking networks. If this kind of stuff interests you, you should go look at the commit logs and the PRs, because there's all these little tricks that people are using to get around proxies and firewalls and things like that. So those are the two things that are super interesting to me right now.
Yeah, that is really interesting. Definitely. Now, what about at your work at Twitch? What's interesting you? What's bringing you in? What are you working on at Twitch, rather?
Yeah. So the thing that I'm most interested in right now is making broadcasting easier, and also making the things that people build with broadcasting easier. So about 2 years ago, I added WebRTC to OBS. Another developer had already started it, where he had created a PR to add WHEP support to OBS. He had written it in Rust, and I got involved and kind of took it over. And so now you can do this WHEP output. And then what was really important to me is I wanted to make broadcasting as easy as possible. So like setting up RTMP and HLS and all the bridging and transcoding is very hard. And so I made an easy self-hosted server called Broadcast Box, where you can just like Docker run, and you can run it on your AWS instance or DigitalOcean instance, and you can broadcast out to your friends very easily. So I wanted to solve these two problems of low latency with WHEP, but also just make it easier to build these things. So that's the thing I care about right now. And there's all these cool parts about it. So now that we have this low latency, I'm going to build it in so that you can pull people into your OBS instance. So kind of like StreamYard, where imagine if you're like all in a Discord room, you could copy a URL and it would automatically pull everyone's videos into your OBS instance. And so locally you could composite, and you'd pull everyone's videos in via peer-to-peer or SFU or whatever. And just like bringing that experience into OBS instead of making people depend on third-party tools. So on the OBS repo, there's a discussion where I've like itemized out all the things that I'm going to do and the path towards it, and I'm like 80% there. So yeah, I could like deep dive on this forever. And then Simulcast is another really interesting one. So like it's so expensive to like decode and then re-encode, and like the quality loss you get out of that. So yeah, I'm really excited with Simulcast and OBS, like what that will enable people to do. So there's like 5 jumping off points. I don't know if there's one in particular that's interesting.
There's a half dozen different ways we could go on this for sure. Let's go to the Simulcast one. What does that enable in kind of an OBS based architecture, let's say?
Yeah. So when doing these broadcasting workflows, the most expensive thing by far is the transcoding. So like how people have typically done this is they will just upload 1080p or 4K, and then at that server it'll decode it, and then it'll re-encode it as like building like a ladder out of it. So for people with lower networks, it'll encode 1080p, 720p, 480p to make things easier. And that's how things have been done today, but it has all these downsides. Like one is you have this generational loss where decoding and then re-encoding, you're actually like you're losing quality. Like you sending 720p direct is higher quality than me decoding and re-encoding. It adds latency. So if you want to have like a real-time conversation with an audience, you can't do it over this like transcode flow. And then it's also terribly expensive and hard to set up. To expect everyone to run FFmpeg on server side and like manage all that and all the air handling that comes with that. These are all things that I really wanted to solve. Yeah. And so with Simulcast, instead you encode all of that in the client. And what is really cool is since I'm encoding it in the client, I can choose exactly what I want to send. Like I can, if I've got like a bunch of really nice hardware, I can send 1080p and do it the best quality possible. Like my experience with talking to all these companies that do server-side transcode, they're always trying to push costs down. Like if you can, even if you depend on someone doing the transcodes for you, they're always going to be lower quality because these companies are trying to save money. So Simulcast is kind of the way I see it is it's like putting the control back into the broadcaster, that you can have the best experience possible that you care about.
Nice. Nice. Yeah. And you mentioned StreamYard earlier. For those watching this, they may not be able to tell unless they're already familiar with the tool that we use StreamYard to produce WebRTC Live. And that was after having tried to do a more custom workflow in OBS and running into a lot of challenges with that years ago. So I can definitely agree that, in the past, it's not an easy thing to do. And so for the relatively simple workflow that I use in this, it was really nice to have a third-party tool like StreamYard for it. But if I wanted to do something more complex, a more unique flow, I wouldn't be able to do it. I'm obviously constrained by how this tool works. And so going back to something based on OBS would be really attractive in that scenario. And so what you've done with Broadcast Box then basically would make that easier for me to do. Instead of trying to configure all that myself, I can take an instance of Broadbox in the cloud and use that.
Yeah, and I think for a lot of people that are doing like talking head contents or podcasts, that they'll probably continue to use StreamYard because it's so easy, and like you have a business that's like constantly making it better. When I imagine that the long tail of those unique, weird things will thrive in OBS and Broadcast Box and things like that. Like since this is all open source and for fun, I tend to cater more. Well, it's kind of this thing, like I cater more to the weird use cases because
sure,
they're underserved, and so like they'll
right.
they'll those are the people that use Pion, those are the people that use OBS. When you have many businesses competing for you because you've got this workflow, you're making money off it, stuff like that. So it makes more sense to use these products. I don't know. We'll see what happens with OBS and everything else in the future, but I'm definitely more motivated by the weirdos, and like I'm one of them.
Well, hey, it's good to know what interests you, so that's
yeah.
we appreciate it.
Yeah.
But and I would think the other use case for that too are people who maybe come from a more traditional broadcasting background or have a larger team already. They're already big users of OBS in a more traditional broadcasting environment, and so this then creates that opportunity for them to bring in more low latency WebRTC streams into that workflow in a way that they couldn't in the past. So.
And I hear all these weird ones, like they're like, oh, I want to capture an application on my desktop and then send it up to an AI agent to do transcriptions, or there's all these weird things that you can't do with existing, because until a market has been proven, businesses won't build to it. So next gen use cases are always cobbling open source together.
Yeah. You got some kudos here from Malaka watching and saying great job on the broadcast on the broad box. So thanks for sharing that, and for again reminder, anybody watching, you can put in your own questions and comments in here as well. Question I have from Justin asking how easy is it to scale WEP and maybe even start. We've talked before on WebRTC Live about WHEP and WEP, and they have definite application in like an OBS type of scenario. So maybe give us a quick definition of those for those not familiar with the terms, and then talk about how can you scale that in a large scale broadcast scenario.
So WebRTC had this problem where the way you bootstrap the call was never really defined, where I would make I would describe what I could do and you would describe what you would do, and we have to exchange those, but it was never agreed on, like, do we do it via WebSockets? Do we do it via HTTP? Do we do it via Pigeon? Like, no one ever agreed on that. And so WHIP and WEP is this agreement that now we're going to do it via HTTP. And so WHIP says, like, make an HTTP post at this URL and you will get this message responded. And because that we now have this agreement, WebRTC gets this thing of like, here is your stream key and here's your URL. So if you use RTP or SRT, it feels very similar. That's the problem it solves. And then as far as scaling WHIP and WEP, I find it really, really easy because it reuses HTTP, where if you're like defining a new protocol, there's all these things you don't anticipate or you don't realize. And because WHIP and WEP is using HTTP, I can reuse all of these nice things that already exist. I think that's kind of the superpower here, that I can add arbitrary HTTP headers, I can do redirects, I can do, we've had like 30 years now of prior art on how we scale HTTP services that it makes it super easy. Like it's not a new protocol. So that's the superpower here.
Yeah.
And then,
yeah. No, that makes sense. So what is that? What are some of the pros and cons then of using WebRTC in a broadcasting environment?
For me, WebRTC has this. The pro is that if you use other protocols that have higher latencies, you're going to have two systems. Where if I want to use if I want to use a protocol with higher latency, and then I have users that come to me and say, hey, I really want low latency, you're going to have WebRTC and your other protocol infrastructure. But with WebRTC, the problem is, okay, it can do low latency, but the challenge is growing it up to do higher latency, and which is a solvable problem. You know, it's a solvable problem. Like it will take work and we'll have to figure it out, but it's an intractable problem to grow a slow protocol down. Like it's you know, you can't, like, it's the laws of physics, you know, of space. There's nothing you can do about it. And so that's what keeps me hammering away at the problem, because I believe that if I put enough time and I put enough effort in, that WebRTC can cover all the use cases, because you can grow it, you can improve the quality, and I don't know over what time scale it will happen, but it will happen eventually.
Yeah. Now, we in our opening segment today talked about the ComCon conferences, and you were at ComCon San Francisco and spoke there. Tell us a little bit about your talk and sort of your experience in general at ComCon.
I'm a huge fan of ComCon because it's not a vendor-specific event. I go to it and I have all these different protocols and all these different companies that are talking about their thing, and I enjoy it because I sit and I was like listening to talks about SIP, I was listening to talks about Quick. Like I love that I'm not just hearing the same things that I hear about all the time. And because I was there, I learned, I came away with a couple of new ideas that I wanted to do with WebRTC because of that. So I'm a big fan of that. In particular, there was a really cool talk that talked about hijacking the WebRTC session. So you could override, like imagine if I had a plugin right now that overrode like the RTC peer connection object. So every time I open up a web page, it would actually send my WebRTC traffic to a different server, and then that server would then connect to StreamYard.
Okay.
So I want to take that idea back and do something with Pion. Like, could I slurp up Pion traffic with like kind of a workflow like that, where like I like extricate the offer answer from the browser and send it to a third party thing. So yeah, like that's why I like ComCon. It's actually been I had a 1-year-old, and this was the first conference I went to in like 2 years. So that it got me out of like the slump of I don't feel like traveling, I'm not getting enough sleep.
It got you out of your literal basement that you're in right now. We can see.
No, no, this is my beautiful virtual background. I pay a high premium for this.
Oh, we've talked about this before. I know that's not true.
Yeah.
I saw you changing the loads before we went live.
I know I was. Well, and I like that this light right above my head shines off my bald head. It really reminds me of like a downward spiral.
And on top of that, your camera's lower than mine too. So you know,
you made me lower it. You said before, hey, I think your thing's a little high. You made me lower it on purpose.
Well, speaking of good banter between us and also in our opening segment, Justin from our team, who was at ComCon San Francisco, he talked about some banter about Quick over UDP and kind of its relationship to WebRTC. Tell us a little bit about that.
Yeah, I see all of these multiple efforts to bring media over Quick into the space, and here's some of the things I've heard about that are exciting. Is that media over Quick, it talks about this idea that we will only have to have one server. So instead of having your like WebRTC media servers and then your HTTP servers, you just have one server, and it covers everything, which does sound interesting to me. Like that would be great if we had that. The other thing I hear is switching to Quick is like, imagine if like we all want to get to one place where we have like really easy video infrastructure. And right now we're on the WebRTC road, but it has potholes and all these problems. But and I don't want to start over because I feel like we're getting to a destination. But someone told me like, so let's start over on this quick road, and because quick is a better road, we'll get to our destination faster, even if we have to start the trip over. So this is kind of that existential problem I have. I'm like, should I start over? Because I've like worked so hard to get it in clients and make it in like compliance testing, all these things. So that's kind of my existential crisis. I do have one thing that frustrates me about some of these quick talks is that things are factually incorrect about WebRTC. So there was this like point of, you can't tell information about a video frame unless you've depacketized it. But WebRTC does. They have that generic frame descriptor. I can see like, so it's hard for me. Like I get caught up during a talk because I latch on when I hear, like when, it's like during a speech, when you hear someone say like one thing that's incorrect, you latch onto it instead of listening to the entire talk. You're like, no, that's BS. Like I hear that one thing. So I had some of that problem. And then the other thing I don't know is what are the performance implications of doing everything in JavaScript? So if you like decode and then you have to copy all those frames out of JavaScript back into memory. So the nice thing about WebRTC is it's like all living in C++. So it's not like doing all these back and forths. I don't know. Like I have all these musings and I don't have an answer. I think like I try to have as frank a conversation as possible. But the one thing I do hold that is very important to me is I want video to continue to be easy for beginners. And so like, I think in my perfect world, I would want to keep something like, I would get rid of RTP and SCTP and replace it with Quick, but I would want to keep the offer answer exchange and I would want to keep ICE so that we could still have, I don't know. Like, I don't know where these things land out. And honestly, I don't enjoy the standards process because it's so fraught with like politics and business. Like, because businesses come into that and they're pushing different things because they care about the use cases and there's a lack of empathy and understanding. And I like open source because it's just like I'm closing people's bugs and I'm helping people and like I don't have to worry about all that.
Yeah, so, and sometimes those the weird use cases or the weird people, as you were joking earlier, aren't necessarily going to get the attention in the standards body, right? It's a standard. They're trying to cover as many things as they can, and maybe at the exclusion sometimes of those weirder use cases that an open source project or an alternate implementation might help with. We have a question from Alberto asking about how can WebRTC broadcasting provide HD quality consistently, and how? What are some of the considerations for people out there to know when building something and they want HD quality?
Yeah, people do that. People do 4K over WebRTC today. Like you, on the receiver side, you control how much you buffer and how much you accept. So like WebRTC, there's this misconception that WebRTC is like tuned to be, something for like low latency, or it's tuned to be for low bit rates. WebRTC is just a road, and you decide what kind of card you put on it. Like with WebRTC, I can set the RTP playout header to be 3 seconds, and I can push 4K, and like nothing says that I even have to use the browser. So yeah, like I that's what I hope to solve with things like WebRTC for the curious, is like someone can go read that and kind of like pick the pieces together. Like, hey, there's nothing in here that says anything particular about. It's fun. It's also funny to remember that like at one time, if someone said you were sending 480p H.264 over the internet, I'd be like, that's impossible. Like this is 2003. We could never do something like that. And so like, but now like we act like, oh, that's magic, and it'll be the same. These things are always changing, and like what we would perceive as high quality now will be like table stakes in the future.
Yeah, absolutely. So what's next for Broadbox, and is that also being built with Pion? Is it you intended for that to be a community-driven project as well? People contribute to that. What's the sort of the plan there?
Yeah, so it's completely open source, built with Pion. People can contribute to it today. If you go to the README on there, it links you to a Discord channel where you can go and like talk to the contributors, and it's really just driven by what people want with it. Like the dev community the dev community of Broadcast Box is very different than Pion. Like I feel Pion is more people that are developers trying to build things for the business, when Broadcast Box is more like individual program, like individual self-hosters, like they'll send like one-off PRs to do like to solve their unique problem. Very different communities, but I enjoy them both. But yeah, like join that Discord. I'm there. I'm idling. I talk to people, and lots of opportunities. And that was actually like kind of my talk at ComCon. Like I originally wanted to write a talk on WHEP and WHEP, but I actually just blabbed for 20 minutes about how much opportunity there is for like your own personal happiness and for your career to get involved in WebRTC. So yeah, Broadcast Box is one of those opportunities. Like if you want to learn C++ and you want to write Go and do WebRTC stuff, I got a lot of stuff that I could use help with.
Nice. And where do people go to learn more about Broadcast Box, by the way?
There is I can put it in our private chat. This is the actual URL to it, and so that's the best place to go.
Okay, copy that and put that on the screen here.
Yeah, and in the README, there's a link to like a Discord channel server. I don't know the lingo anymore. I'm out of date. You know, someone made fun of me that I say for PM instead of DM. I didn't realize when this changed.
I don't know either. I guess I'm out of date as well. And then, of course, we've got the Pion project too, I assume, kind of linked from there as well at pion.ly.
Yep. So yeah, those are the Pion.ly and then WebRTC.ventures.com if you want to learn about the protocols. Those are the three things. And there's other things floating around. It's hard. There's not like a central place for WebRTC info well, I guess this is the central place. Like you watch WebRTC Ventures.
That's right. I'd like it to be, but there's a few ways to find things out there.
Yeah. No, but there really isn't like a central place, like because you have like these very disparate communities. You know, you've got like, because I talk to people that like work on Jitsi and they're like they have no conception of the things going on. I have no conception of what goes on over there. So this is that neutral meeting zone where we all be.
I'd certainly like it to be. So I appreciate that. And let's talk briefly too as we wrap up. We're nearing the end of our time here, but there's also a close relationship between LiveKit and the Pion project. Talk a little bit about the distinction between those, and what are kind of the different scenarios where you might use one over the other, or how that works.
Yeah. So Pion was started 6 or 7 years ago, and it's kind of like this low-level building block that was targeted at developers. And then a year or two after that, someone made this project called Ion that was like this higher level thing so that you could build servers easily. And then LiveKit was a fork of that. And where LiveKit really thrives is for people that don't care, like they don't want to fight with all those small details. Like I want to build some live video infrastructure, and I don't want to have to deal with all of I don't want to have to discuss the intricacies of RTP extension headers. I just want it to work. And so that's where LiveKit thrives. And you've got SDKs for mobile, and you can do WHEP and WEP and SRT, and it solves all of those problems for you. They worry about the details of video, and it is just Pion is one of the libraries they use to power all of that.
Nice.
I think that's a good elevator. Honestly, you know better than me. I feel like you spend a lot of your time like.
No, I think that's great. Yeah. I think that's great. Excellent. Well, anything else, kind of closing remarks or thoughts that you want to share with our listeners today, Sean?
The usual pitch of if you're out there and you are frustrated by your job, you want to build something, you want to learn something new, I'm always available to give you projects or cheer you on or convince you to do something interesting. That is like what I want most. So if you're watching this and you're like on the cusp of getting involved in open source, reach out.
That's right. Yeah, if you don't already own the domain name, Sean, the alternate to WebRTC for the curious should be WebRTC for the passionate, WebRTC for the ambitious. Sean can help you with all of that. And you have a lot of passion that you share with the community. So really appreciate that. Thanks again for joining me today, Sean. Always great to have you on WebRTC Live.
Thank you so much.
All right. Now, remember to stick around. I'll have Sahi joining me in just a moment for an industry analysis segment. And we'll be talking about Simulcast and WebRTC more there. First, let me remind you that this video will be available on the WebRTC YouTube channel, as well as on our blog at WebRTC.ventures. And our next episode of WebRTC Live will be Wednesday, July 10th at 12:30 p.m. Eastern US. Our guest will be Chad Hart from WebRTCHacks.com. Another good place to learn about what's going on in the WebRTC world. And to find out more about our upcoming episodes in general, follow us on social media at WebRTC.Ventures on Twitch, LinkedIn, YouTube, and join our email list at WebRTC.Ventures. Thanks to all of you for joining us today. Appreciate your kind comments about the conversation with Sean today. So make sure that you check out Pion and WebRTC for the Curious and Broadcast Box, and also us at WebRTC.Ventures. Let's make it live. Thanks for joining me today, Sahi. Let's talk about Simulcast and WebRTC. You blogged about this recently on bloggeek.me. And so similar to how you opened that blog post, I think it's important, maybe before we start talking about the details of Simulcast, give our viewers a quick overview of the term bitrate, please, since that's going to factor into the conversation a lot.
Okay, so when you try to look at a call, a video call, and there are multiple users in that call, you need to send data towards these users and receive data from them. Okay, now bitrate is limited, like any other resource that we have. Bitrate is highly limited, although we think that it isn't, but it is, especially the low latency kind. So we try to limit the amount of data that we send and receive. Okay, so let's say I need to send data to 4 participants, but one of them has a poor network or is on his phone. So he needs to get less bitrate than others. What should I do? Should I send everyone low bitrate because that's what this guy can handle? Should I decide not to send him video? He'll get only audio. Or should I try to send him something that would fit him and send others something that is of a higher quality? Now, the bigger the group, the more such issues with different limitations and capabilities of each user that I'm going to bump into and will need to solve. And that's, I think, where Simulcast comes in.
All right. So what we're so tell us about Simulcast. And Simulcast is, we're going to try and avoid those lowest common denominator situations, correct? Of that one person on the mobile connection, bad network. So how does it solve that?
So in WebRTC, we're trying to be as lazy as possible on the infrastructure side. And that means that we're trying to reduce our costs of running the service. So whatever we can offload towards the devices, we are going to do that, because that means paying less for the service. Okay, as a service provider, I really don't care about your device. So what
buy bigger memory, it's your problem.
Yes, exactly. So it's not like if Netflix is going to send a movie to people, it's going to send it in different bit rates based on each user's device at home. They can do that because they have one movie and they need to stream it to 1 million users. And they do it offline. But with us, it's like, it's a call, 4 people. I'm not going to spend my server performance for that. So what we're going to do is use Simulcast. And in Simulcast, each device is going to generate more than a single video stream for the same content. So let's say I'm in a call. I'm going to do a low bitrate video stream, let's say 150 kilobits per second. This one is for the mobile device. Then I'll do one at 500, 550 kilobits per second. Okay. And then I'll do the third one with the rest, 1, 2 megabits per second. I'm going to send all these to a media server called an SFU, a selective forwarding unit. And now that server has a menu of different bit rates to choose from and to send to each and every participant based on the needs of each and every participant. These needs can include how much bandwidth that user has, how much CPU it has available to decode all of that data, what is a screen resolution. I don't want to waste high bit rates and resolutions on small screens, for example, not worth it. And even what layout is being displayed. Different people might view the same meeting in a different layout and different way. So again, the layout is going to define what resolutions they actually see things. And again, I don't want to send higher resolutions than what is being displayed, because that's wasteful and we don't like waste.
Yeah. Absolutely. Now, you mentioned SFUs in there. So, Simulcast only works with an SFU media server, correct? With an MCU, it would at least work differently, right? I mean, you're not allowing any change on the client side.
Let's do two things. First of all, there is an MCU and an SFU. An MCU is for those that that can work with expensive backend equipment where all of the encoding, decoding, compression, mixing can be done on a server. That's like the old guard of how you do things, or when you need to record things and stream it live or broadcast it into YouTube Live or whatever. Then use something like an MCU, a mixer. There you don't use Simulcast because you don't need Simulcast. Okay. There's an SFU that routes the media around. Usually you have Simulcast there. Almost by default today, it's quite common. And SFUs are the most common media servers in WebRTC. The reason I was like, not exactly, is because I am sure that there are use cases where you use a different type of a server that is an SFU, but is not called an SFU, that you can use and do use Simulcast with.
Fair enough.
I don't want to be that. Only SFUs.
We want this recording to last, this conversation to last for on. Maybe someday tomorrow somebody's going to invent something else. But no, definitely one of the reasons, one of the benefits that you get of using SFUs, why they're predominant media server architecture to use. Now, you talked primarily about the need for the different bit rates and handling the different resolutions in like low network conditions, like somebody on a mobile network. You hinted at, but let's talk a little bit more about use cases where you might intentionally use a lower bit rate on some streams, regardless of the quantity of bandwidth available, right? So thinking, things like video thumbnails for the person who's not speaking is one, I know.
So I think, let's say that I want to share something in this meeting. In this thing that we're doing. I'm going to share my screen, and the moment that I do that, we're going to be small thumbnails next to that video, okay, somewhere on that side. Now, once that happens, I don't really want to send high bitrate to the people that are going to watch it that way. Because if I send that at a high bitrate and everything is high bitrate, I need to first send more data. Let's say I've got that data, but now I need to decode two high resolution videos, where one of them, after I decode everything, I'm going to scale it down. So I'm going to spend more energy sending it, more energy receiving it, more energy decoding more bits, and then more energy because I need to scale it down. Okay, so this is one instance where I don't want to do that. The other one is, let's say that we're watching this on a smartphone. Now, I don't know about you, but mine is like 5-inch, 6-inch, whatever. Okay. You can put 1080p here. That's fine. You can do that. I can't see 1080p on this kind of a device. I won't notice the difference between that to 780p, and probably not with VGA.
Yeah.
Done with good enough bitrate. So this being the case, again, I won't spend too much effort on that device. So it's not only resolution, it's also screen size. Then there's the matter of how important the video is. Let's say it's a large classroom. We have 30, 40 students in that classroom and one teacher. Guess who's going to get all the bitrate?
The teacher. Yeah, exactly. Who's the focus of this meeting, of this conversation?
Let's say that someone is raising his hand and asking a question. We're going to give him more bitrate for that part of the call, but then we're going to take it away from him. And we're going to do that by checking audio volumes or hand raising in the application or whatever. Different ways of doing the same thing. But at the end of the day, I need that flexibility, that original menu of I've got different bitrates and I use different ones to different users in that scenario, and I switch in between them dynamically as well.
Now, talk about are there switching costs of doing that sort of thing on either the server or the client side, depending on where it's being done?
Everywhere. So first of all, let's go to the fact of let's start with the naive approach. I send 3 different bitrates. Usually Simulcast is 3 layers, low, medium, high. I'm going to send all 3 of them. Now, let's say that I'm a shy guy and I'm muted in the call. So if nobody sees me, I might not even need to send the media to the server. Okay, and that is going to be very, very beneficial to everyone.
Mm-hmm.
Or I might only decide to send the lowest tier of bitrate. Let's say that all of us have a great network. I might end up sending only the highest bitrate of one of the users to everyone all the time, and I can forego using the others, or I can keep the medium one if I need to go down because of packet losses of someone or something like that. So there are different strategies of saying, well, if nobody is watching, don't send it. That's one approach that you can take.
Mm-hmm.
The other one is if you look at the server, okay, it now has a lot of things that it can look at and decide what to send to whom. And again, that menu of choices is something that it can optimize with, but in order to make that decision, he needs to understand what happens on the clients, and he needs to be aware of the application itself. So I need to know what is the layout of each one of the users, what they see on the screen, and which videos are important and which ones aren't. And this is application logic. So for me, an SFU is a big kind of a building block that adds flexibility into the solution.
Mm-hmm. Absolutely. All right. Well, Sahi, there's a lot we could talk about in this. We're kind of at the end of our time now, but what's interesting to me about this conversation is how much it touches on like the media server architecture, the application logic, as you were just saying, as well as the user interface design and how you interact with it. Do you, as the individual client, have the ability to change your layout versus only, say, the teacher in that classroom scenario? So this affects a lot of different use cases and things you need to think about when designing your application. But Simulcast enables that, SFUs enable that. So there's a lot here to learn. So where can our viewers go to learn more about topics like Simulcast? I know you have a lot of courses and do a lot of great blog posts.
So there is bloggeek.me, where the post is there. There is more information there. There is WebRTCcourse.com, where I have my courses. And then just search it on the web. There is a lot of resources there, some better than others. But, just go and search. The data is out there.
There is a lot out there, and certainly your content comes up pretty high whenever you're searching any of these terms. So we appreciate you sharing the expertise with us, as always, Sahi. To learn more about Sahi's work, as he said, and sign up for his courses, you can start by checking out bloggeek.me. To learn more about future episodes of WebRTC Live, visit us at WebRTC.ventures. Thanks for joining me, Sahi.
Thanks, Aaron.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.